In this video, we'll learn about influential observations. An influential observation is a data point that significantly changes the regression line, the slope, the y-intercept, or the correlation coefficient. The key idea is this. An outlier is a point that is far from the regression line. An influential observation is a point that causes the regression line to change when it is removed. Notice that these are different ideas. A point can be an outlier without being influential, and not every outlier is influential. To determine whether a point is influential, we'll compare two regression equations, one using all the data, and one with the suspected point removed. Let's apply this idea. A dealership wants to predict the selling price of a car based on its age. Since we are predicting the selling price, the price is the response variable, y, and age is the explanatory variable, x. Question A, we want to create a scatter plot and then determine if there's any point look like an influential point. So let's use the TI calculator to do that. First, let's enter the data into the calculator. Press Stat, Edit, and press Enter. Enter the car age into L1 and the price into L2. To open the Stat Plot menu, press Second and then Y equals. Turn on Plot 1. Choose the first type. For X list, enter L1. Y list, enter L2. Press Zoom and go down to choose Zoom Stat and press Enter. Looking at the scatter plot, this point stands out from the rest of the data. This is our suspected influential point. So what is this point? To read this point, press Trace and use the right arrow to move to that point. So this point has the x-coordinate of 15 and y-coordinate of 35. This is our scatter plot, and this point, 1535, stands out from the rest of the data. This is our suspected influential observation. Now, let's see if it really is an influential point. To do that, we need to find two regression equations. The first one is the regression equation using all the data. And then the second one is the new regression equation after we remove this point. Okay, so now let's go back to the TI-84 calculator to find the regression equation using all the data. Now, we need to check to see if this is actually an influential point. To do that, we need to find the regression equation of this data. Press Stat, move to Calc, and go down to choose number 8 and press Enter. For X list, enter L1. For Y list, enter L2. Highlight Calculate and press Enter. This is the regression equation using all data. This is the result from the calculator. Let's round to 3 decimal places. Y hat equals A plus BX, and A is 19.384, B is 0.703. So, my original regression equation with all of the data is y hat equals 19.384 plus 0.703x. Next, I need to remove this point and then recalculate the regression equation. So let's go back to the TI-84 calculator. Next, we need to remove that point 15,35 and then find the regression equation without that point. So go back to Stat, Edit, and remove this point. So highlight 15, delete, highlight 35, delete. So this is the new data without the point 15,35. Press Stat, go to Calc, go back to number 8. For X list, enter L1. For Y list, enter L2 and calculate. This is the regression equation without that point. Now, let's compare the two equations. This is the result we got after remove the point 15,35. So the new y hat equals 30.2 minus 2.629x. This is the regression equation with all the data. This is the regression equation with the point 15,35 removed. Now, let's compare the two equations. The slope of the original equation is positive 0.703. The slope of the new equation is negative 2.629. The y-intercept of the original equation is 19.384, and the y-intercept of the new equation is 30.2. Notice that both the slope and the y-intercept change substantially. Since removing this point produces a large change in the regression equation, we conclude that 15,35 is an influential observation.